thanks so much for having me. Thanks to the organizers for the nice conference. So this is joint work with Bruno Conte and Klaus Desmet, and it's part of an agenda that we've been working on for some time on trying to think about the spatial consequences of climate change and how it affects the different places in the world and how the different types of adaptation mechanisms across space can affect the overall aggregate cost of this phenomenon. And this paper, we've been developing these frameworks to study this question. And at some point we were thinking, well, let's, do the obvious policy, put a carbon tax on some regions of the world. And we were getting results that we couldn't really understand very well. And so this paper is a little bit of the result of our confusion on this. So carbon taxes or some form of carbon pricing is perhaps the most straightforward or obvious way to alleviate some of the consequences of climate change or try to prevent it from happening. And the logic is very simple. It's standard Pigouvian logic. There's a social cost of carbon, there's a private cost, and the tax allows you to bridge the gap between both of them. And so, countries are, there's some politics as always involved in these things, but I mean, many countries are trying to impose some form of carbon pricing or carbon policy. So it's natural to try to think about what are the consequences of doing it, and in particular, what are the consequences if one particular region of the world, and in this example, the European Union, does it on its own. So I'm going to think about this exercise, the European Union imposing a carbon tax within the European area, and no one else kind of really doing it either. And think about what are the spatial consequences both within the European Union, but also across areas of the world. And in particular, we want to think about sectoral specialization, to what extent the tax itself affects different sectors differently, and through sectoral specialization affects the comparative advantage of different regions in the world, and through changes in that comparative advantage, linked also with migration responses, whether that kind of just try to understand that within and across regions in Europe. And to do that, we're going to use one of these frameworks that we developed somewhere else, and in a paper also with Bruno and Klaus and also David Nagy, which is like a spatial dynamic model of the distribution of economic activity that has two sectors. One is agriculture and one is non-agriculture. Okay. So let me just go through the model. It's going to be a little bit impressionistic view of the model, because I don't have time to go into all the details, but hopefully it's going to give you a little bit of an idea of what are the main forces at work. So think about a world economy that is divided into these areas that in the application are going to be 1 degree by 1 degree squares. So that's 64,000 squares in the world. And there's a population that lives in the world, and it has preferences, kind of period specific preferences that are given by the expression that you see there. So, and so there's many terms here. So let me go through them. So there's some for an individual at T, that individual J at T that has a history of where that individual has been R minus and is today at location R, experiences some amenities from being in that location, this AP. Then it consumes a continuum of goods that it aggregates CS in two different sectors, I. One is going to be agriculture and the other non-agriculture in the application, that are aggregated Cobb-Douglas, which shares chi-I. Then there are some idiosyncratic preferences for the location. Some people like it better in the location, some people worse. And then there's some migration costs from having moved along that history across locations. And so here I'm going to have two basic congestion forces in the model. One through these amenities, that I'm going to say that amenities are lower if the density of people in a given location is higher, so this lambda is going to be positive. And then these idiosyncratic preferences that come from one of these extreme type distributions that where if you put a lot of people in one location, you're kind of getting people that marginally like it less in that location. And so that acts also as a congestion force. Okay, so two congestion forces there. And then this migration cost, I'm going to actually simplify that a lot because I'm going to assume this kind of log linear form from the migration cost, which implies that this migration is reversible essentially. So I go to wherever, you know, is the optimal location today, and then tomorrow I get kind of to re-optimize again, and the migration cost that I paid while I only kind of pay migration cost while I'm in the location that I selected. And so that essentially makes the migration decision a static decision, which simplifies this problem a lot. So that's the consumer side. Then there is the production side. So think about production per unit of land of some variety omega in industry I at location R. It's produced using three inputs: labor, energy, E, and then land, H. It's Cobb-Douglas, constant returns in all of them. And then you have, the firm can also invest in innovation, and that's this L fee here. So the way this works is the firm has some distribution of productivities from which it draws every period that determines the current productivity, but it also has this option to invest in improving its productivity, which essentially shifts the distribution from which it's drawing. Okay, and so that makes it a growth model in essence, where you know the distribution from which firms are drawing is shifting over time as firms invest in the technology, and firms are going to invest according to their market size. So if their market size is very large, I can sell many goods, then it's worth it for me to invest in technology. I'm going to invest more, and so growth in that region is going to be faster, right? Or growth of the productivity of firms in that region is going to be faster. And so the mean of the distribution from which these firms are drawing is going to be the Z, okay, which is going to be determined by tau. This is like a dynamic term that I'll explain in a second. There's going to be an agglomeration effect, like standard density agglomeration effect that is governed by this parameter alpha. And then the temperature, the green, the term in green is the effect of temperature. So we're going to allow temperature to affect the productivity in a given location in a given sector. Okay, so this is where temperature is going to get in, and I'll explain this G function in a second. Now this dynamic effect, the tau, follows this expression here. And so tau today is tau yesterday, and then is upgraded by how much firms decided to innovate. So that's the innovation, that's the pushing of the distribution that I was mentioning before. And then there is this term in brackets here to the 1 minus delta, which is a diffusion of technology across locations. So that's a kernel of the levels of technology in other places of the world. And this is, you know, not some sort of extra wrinkle of the model. That's actually needed in order for the model to converge to a balanced growth. So that's kind of you need some diffusion of technology in order for that to happen. So because technology diffuses period by period, when firms decide whether they want to invest in better technology or not, what they're looking at is, well, they want to win the competition, the local competition for land, for the ability to produce in a given location, but they know that tomorrow, you know, the rents are going to be again competed away by firms that want to try to enter into that technology, and they are going to have access to the same kind of level of technology that they do. And so what that implies is that all the rents of those innovations are going to go to the fixed factor, which in this case is land. And so that again, from the investment problem of the firm, they see, well, I need to innovate in order to win that competition today, but from tomorrow on, I see zeros in my profits which implies that I'm just optimizing today. And so even though there's perfect competition, there is innovation in a given period. But again, I'm just optimizing to win the competition for land today. And then the trade part of the model, the final part is the trade part of the model, is all you know, standard gravity, Eaton and Corton stuff. So I'm not gonna really say more than that about it. The piece that I have to just get specified is the way temperature is going to enter productivity, which is that G function that depends on the sector. And we're going to assume this kind of exponential function. I'll show you some examples of this that is going to be parameterized by two objects. So some sort of optimal temperature GI up and the variance of these objects. And I show, and we're going to allow that to vary by sector. And so a temperature is going to affect different sectors differentially. Okay. And then the rest is just the basic carbon cycle. If firms use energy, that adds to the carbon stock on Earth that accumulates into this KT. KT then in turn affects global temperatures, and these global temperatures then affect local temperatures. And it's these local temperatures what enters into the local productivity. Okay, so that's your standard feedback from the economy into climate. Okay, so that gives you that feedback. And so we're going to add carbon taxes in the you know, straightforward way, and it's going to make the energy input for firms more expensive by some fraction YT here. And because the share of energy in production, remember our production function is Cobb-Douglas with a share of energy that is governed by this sigma, this parameter sigma that is crucial. So sigma is the intensity of production in industry I in energy, okay? And so the marginal cost of a firm is going to depend on, of course, on the carbon tax raised to that power sigma, okay? So sigma is key, and sigma is going to determine, you know, depending on what sector has the higher sigma, that's the sector that is more affected by the carbon tax. And so that's exactly because there's variation in sigma across sectors, the tax is going to change comparative advantage at the local level, right? So that's key. And so we're going to then impose this carbon tax. And then there is the added issue of what happens with the revenue of the tax. So there's some revenue that is going to come in with the tax. And this revenue and how you redistribute this revenue is going to be key, as I'll show you in a second. And so I'm going to show you different versions of it. The first one, just to simplify things, because otherwise there's like too many things floating around. I'm just going to drop it. I'm just going to, you know, eliminate it, throw it to the sea. We're going to see the effects just as a baseline, just see the effects. And then I'm going to bring it back in these different ways, either locally redistributed or European redistributed or world redistributed. And you're going to see how that matters a lot for the different results. I mean, the standard way of quantifying these frameworks is to take the framework, take data at this level of disaggregation that we're working on, and essentially what invert the model, what's called inverting the model. So I'm going to find the productivities and amenities in both sectors, so productivities in both sectors and amenities that exactly match the distribution of in the data that I observe. Okay, so the model in some sense has enough degrees of freedom to exactly account for the data in the baseline period. Okay, and then I also need to get those migration costs, and I'm going to get the migration costs so that the model replicates the flows, the net flows in population across the first 5 periods that I observe in the data. So, but for the first 5 periods, I know that the changes in population at the local level are exactly what the model can reproduce, exactly what we see in the data. Okay. And then the last part is just the climate part. So let me go over that in a little bit more detail. So we're going to take one of the IPCC scenarios, or the Intergovernmental Panel for Climate Change scenarios. It's a pretty extreme scenario. So it's what's called representative concentration pathway RCP 8.5. And so that has a bunch of, so that's a scenario that they put forward that says, okay, this is what's going to happen in terms of temperatures, etc. You know, in the business as usual type of scenario, etc. Right? And we're going to say, look at what they say in terms of the increases in gigatons of carbon, in temperature, etc., and calibrate the parameters of the model so that we exactly hit that. Right, so the model is going to exactly hit the carbon implications of that framework, and then we're going to map that down into locations using this standard linear function, which is also kind of very standard in the scientific literature, which says, well, if you have global temperatures, you can map it into local temperatures just with a constant coefficient here that is location specific. So, but it's constant over time. Okay. So that's the first part. That's going to give us the local temperatures. And then the last part is how to map these local temperatures into these damage functions, the G function that I talked about before. And so essentially, we're going to get these damage functions are going to look like this. So the way to think about what we do is we're going to get the agricultural one, the blue one, from data from agronomers, right? So agronomers tell us what's the optimal temperature for crop production on average, etc. And so we're going to get that from them. That gives us the blue one, right? And then we're going to get the red one for non-agriculture so that the model, so as a fit of temperature on the distribution of productivities that we recover from that inversion. And so what that gives you is that in agriculture, you have an optimal temperature that is higher, and the decline as you move away from that optimal temperature is more severe, consistent with the effects being larger in agriculture, right? So variation in climate being larger, affecting productivity in agriculture more than in manufacturing, where the variance is larger, right? And the optimal temperature is a little bit lower, okay? So that kind of makes sense. And it's broad. It's also consistent with lots of other work that we've done where we've looked at kind of time series variation at the local level and try to estimate this more for the whole economy. And you can also use that for kind of the non-agricultural part, but you would get something relatively similar. Okay. From the data, yeah.
You know, might just reflect. I'm sorry. I was asking why is the temperature lower for manufacturing, because this might just reflect that you know, richer and more technologically advanced countries are in temperate areas. Yeah.
No, that's true. But so you can get it also from the time variation and look at like changes at the local level and see kind of what's the effect of changes in temperatures on productivities at the local level. And you also get that an optimal temperature is not like, you know, there's some standard errors around it for sure, but you also get that the optimal temperature is around there, right? Okay. From the time series variation, not just from the cross section. Mm-hmm. But I mean, I guess my other answer, which is, I mean, maybe econometrically not so well grounded, is that, you know, I see the world and I say, well, you know, all the rich parts of the world happen to be in the latitudes, right, where this temperature in some sense is exactly at these levels, right? So that, you know, also, you know, we can decide to throw that away, but because obviously there could be other confounding factors, but it's kind of it's there in the data very strongly, right? So in some sense, my take is we don't want to throw that away because it's a very, very strong empirical regularity. But I think there's an issue of, well, can we corroborate that with time series variation as well? And I think we can.
Esteban, before you get to the exercise, so clarification about the migration part, like the labor migration across. Okay. So what is that pins down the, say, the migration cost and the extent to which workers can migrate across countries? Yeah.
Okay, so it's all migration. I mean, the way we're going to think about it is all migration across these squares. Right. Which of course includes
could be countries, but
within,
could be within
and across,
okay.
Right?
And the cost don't they only change in the distance, or
there's an origin and a destination
Alright.
effect.
Okay.
So it's not by distance, because distance would be bilateral. While
Okay.
this only has
It's-
an origin and a destination effect.
Okay. So it's more general than that.
It's less than general.
Oh, but no origin. Oh, origin destination. I see.
It's
Okay.
log linear in an
It's log
origin
linear
and
in an
destination,
origin,
but it
okay.
doesn't have like a bilateral.
And doesn't have a
effect.
bilateral. Okay. I understand. So it's not like.
But one thing is that because in this type of model, right, the only thing that matters at the end of the day is the total number of people in a location, right? Where, and not exactly where they come from, right?
Mhm.
The fact that you don't have bilateral costs doesn't restrict the model to match the data on net population changes over a particular period. So that's
No, I was just
thinking.
thinking. I mean, that within the. I mean, if you compare sort of, if you do this exercise with for the US, say, and for the Europe, one difference is the languages differ a lot across Europe. Okay, and that's a big barrier to migration. I mean, especially for like low skilled labor.
And to the extent
so-
that it's there, it's going to be captured by this cost, right? And
Yeah,
so if
then-
people, no one enters Italy because in the rest of the world they don't speak Italian. We'll capture that in the sense that entering any of the squares in Italy, the cost is going to.
Yeah. Okay.
Fabrizio? Yeah.
It's actually very quick and clarification, but with this log linear representation, how can you separate the amenity from that part? So how is it separately identified?
So one is the level and the other is the changes over 5 periods. So those are the two sources of variation that we're using to identify each. Okay, so I emphasize that the fact that the difference in the sigma, in the intensity of energy in production was key. And so these are the numbers that we're going to use. We're going to use for agriculture, we're going to set it at 0.04. That's the energy use. And for non-agriculture, we're going to, think about mostly as manufacturing. We're going to use 0.07. So that means that non-agriculture is more energy intensive. And so when you impose the carbon tax, it's going to affect non-agriculture more than agriculture. Okay. And then in terms of carbon taxes, there's kind of a wide variety of taxes out there. So the Swedish tax is about $140 per ton of CO2. In the EU, taxes are normally smaller. Certainly in Italy, they are smaller. They're at 0. And so what I'm going to use is I'm going to use a baseline of 40, somewhere there in between, but kind of perhaps on the high side of what's being done today in the European Union. But I'll show you exercises for different levels.
One question.
Yeah.
So in terms of the energy intensity,
Yes.
you have agriculture and non-agriculture, but a lot of the employment share is going to be in services,
Yeah.
and services probably has a lower energy
Yeah.
intensity.
So you're right. It's not obvious once you add all the transportation part, etc. And so, but in principle, it would be good to break it down more. I agree. We haven't gotten there, but I think we want to break it down. But it is true that if you only look, say, at retail, yes, it's a little bit lower. But if you also add like all the transportation and kind of home heating and kind of take the rest of the economy and kind of group it into that services, then it's not that obvious that it's much lower. So that's why we grouped it into manufacturing and kept it at that. But as you're going to see, it's already with two sectors very rich. So we're a little bit.
No, I was just worried of, if
whether the comparative advantage is right. So
exactly.
So that's key. That's
Exactly.
key. We think it's okay, but it's up for debate a little bit. I agree. Okay, so the first exercise I'll do. Yes. Perfect.
Just, not necessarily super important, but for the EU, I would say that the most important thing is EU ETS, which is a carbon tax essentially, and that's like at 80, a bit more than 80. Now it covers half of the emissions, so I guess you're not far from your 40.
So it has fluctuated a lot, but yeah, you're right. And so ETS ETS is, I mean, any sort of carbon pricing is going to have very similar effects than what we have. It's just a particular form of rebating, right? Because you're giving the permits to the firms, etc. So that I'm going to think more about as local rebating. So when you think about ETS rather than a carbon tax, the issue is how do you think about the rebating and who's exactly getting it, right? And with carbon taxes, it's a little cleaner to think about that issue. So that's why we're, but you know, all sorts of carbon pricing should be added to think about this. Okay, so like I said, the effects are going to be a little rich. So then to kind of warm up, I'm gonna do a case where I priced carbon, and then I'm gonna throw away all the revenue. Okay, and so these are the changes in sectoral output due to carbon taxes over time. And so we're going to impose the carbon tax by 2020 here, right? So there's no changes before because we haven't introduced the policy. Then in 2020, we introduced the policy. I have a bunch of countries here. Then I'll show you something more detailed. Bunch of countries here just as examples. UK is there just for comparison purposes. So, you know, we are aware of Brexit, obviously. And then this is the EU average. And so what you see is, you know, overall, in both sectors, economic activity in the EU as a result of the tax goes down, but less so in the kind of more periphery of Europe with no negative connotations, of course, and then you know more so in countries like Germany. So Italy also in this case kind of agriculture goes down. But look at UK. So for the UK. Is much stronger, and then over time, you know, the output actually keeps growing and kind of grows from that lower level. Compare that to non-agriculture. So non-agriculture drops everywhere, right? And a little bit more in a country like Spain, but and then kind of it recovers a little bit, but very different than the UK. So what happens is everything goes down. But Europe kind of specializes a little bit more in agriculture relative to non-agriculture, and countries at the periphery, like the UK, that don't experience the tax, you know, change very much in that direction, in the opposite direction. So they are at the boundary, they don't experience the tax. So what happens in the UK? They drop agriculture and they specialize in manufacturing or non-agriculture because Europe is doing a lot less of it. Okay, so that's the effect. And so this is in a map. Now each one of these squares that you see there is one of the regions that we're talking about, right? And so see what happens. This is agriculture. In agriculture, you know, the boundary of the European Union drops agriculture, right? These areas, like the more boundary areas of the European Union, specialize more in agriculture, and then the core a little bit less. And then this is non-agriculture, so it drops pretty much everywhere in the European Union. And here you see no boundary effect. Right, so you see here a very clear boundary effect for agriculture. For non-agriculture, you see no boundary effect. Why is that? It's kind of the combination of two effects. On one hand, they lost comparative advantage, or sorry, they gained comparative advantage in non-agriculture, but also they were trading with a region that is now much more depressed than it was before. And so that kind of those two effects combine. Okay, this is. No effect on trade costs. So we're keeping this iceberg trade costs, and we're yeah. I'm trying to think in our calibration where we have lower trade costs in agriculture. I think no, but something we could add. It's an interesting point. We haven't really thought about it, but yeah. Okay, so this is by 2100. So by 2100, if you have changes in comparative advantage at impact, those kind of amplify over time. because of this kind of endogenous investment process that we mentioned, that I mentioned. And so you see that the boundary here of Europe now is much more specialized in agriculture, and then some of the boundary and in the kind of outside of Europe is now more specialized in non-agriculture. But and then you also see a little bit of the effect of climate change, where some of these regions now drop agriculture because they are less warm, so they didn't get as warm as they would otherwise get because of the carbon tax. And for non-agriculture, now you see kind of this area here growing because of this balance of forces that I mentioned. Now it's still not so good to be close to European Union because it's depressed, and so that means that areas that are a little bit farther out start investing in it. But you know, the broad picture is kind of you emphasize the effects over time. So this is across levels of the tax. So remember, we have a tax of about 40. So these are the effects on overall population in the European Union, real GDP, and then sectoral outputs. But all of them decline for all taxes. You know, as you grow the tax, it kind of declines monotonically for all levels of the tax. And this is in per capita terms. So GDP per capita falls, welfare falls, and the only thing that happens is that output per unit per capita in agriculture grows a little bit. So Europe gains comparative advantage in agriculture, which is what I've been telling, right? This is for the world as a whole. So again, this is 2021. Europe declines in terms of real GDP. The countries that benefit are the US, Japan, some of the other rich countries that now gain markets in non-agriculture. But Africa and Asia kind of lose as a result of this, because now Europe is kind of competing with them, or not the most industrialized part of Asia. So China here, no, but I mean, but this kind of more inner part of Asia and Central Africa, they lose because of that competition, and they lose a lot of population as a result of that, and that kind of is very persistent over time, right? So as you can see, and here you can see the effect on climate change, right? So you start these areas in the very northern part that were benefiting from climate change now benefit a little bit less as a result of the tax, because the temperatures don't get as warm, okay? And this is, okay, let me just drop this. It's the same thing. Okay, so this is on emissions. What?
You know, now seeing the results, I think it's key, you know, this idea that agriculture is less energy intensive than manufacturing.
Yes.
So, you know, but if I remember correctly from looking at this data, the agriculture, it consumes a lot of energy, you know, because it's very mechanized. So I guess in your numbers, you are taking this into account.
Yeah.
So maybe it's surprised.
So the share of agriculture we have, right? So like the energy
The
share
energy
in
intensity
agriculture,
of agriculture.
that we know, right? So I'm very confident about that
Yes.
number. The rest is an aggregate that is a lot harder to compute, exactly because it's an aggregate that is formed out of a bunch of things. We're pretty sure about the manufacturing number, and then the remaining is a little bit of an issue.
Construction, where are you putting it, for example? Because
In non-agriculture.
in non-agriculture. Okay.
Everything else is in non-agriculture. So our non-agriculture is really big compared to
Yes.
agriculture. I mean, that's the other thing, right? So what happens in the aggregate is very much dominated by non-agriculture.
Yes, but I think, you know, it's important because construction is non-traded, right? So when you have these comparative advantage results, you know, whether Europe is going to gain comparative advantage in agriculture or not, I think it's key to separate these non-traded sectors, right? Yeah. And, you know,
but you can think about manufacturing, and the way we're thinking about manufacturing in that sector, it like that's the tradable part of that sector. That's the part that kind of you can send out or not, and then there's like a component that you cannot send out, right?
But the other thing is that the manufacturing sectors that have a higher intensity are usually the ones producing less complex goods, not like basic chemicals, etc., which is not the ones that Europe has a comparative advantage. I mean, I would think that the manufacturing sectors in which Europe has a comparative advantage are the less energy intensive. So going to a more deep, I mean, I'm just saying that this result might, flip if you
as
are
the
more
German
detailed.
as the German industry that is fighting nails and not to have the embargo. But anyway, I mean, fair enough. I mean, I think there's an issue about can you get the individual shares at the local level, exactly right. And there's other work that we've done where we've we have substitution between the two types of energy and then look at the relative price or cost of the two types of energy so that you get the shares exactly right at the local level. So you can do that as well.
But something simpler than that. You can say, okay, let me just use the emission intensity of the manufacturing industry in Europe without putting construction or without putting any non-traded goods, right? Just the non-agriculture, but just the traded manufacturing.
Sure, you can do that.
And that maybe you already have a reversal of the result.
Yeah, it's not going to vary sufficiently to get that. So in that other work that I was referring to, it varies, but it doesn't vary that much. So across space. So it's not going to change the fact that agriculture is going to be the less carbon intensive compared to manufacturing. So that ranking, you're not going to change. The extent of that ranking is going to vary across. But anyway, let me continue. We can discuss more. Okay. So then what happens? Total emissions in agriculture grow as it moves to some of these some parts of the world in sub-Saharan Africa and Asia that are less efficient in producing, and then emissions in non-agriculture fall because it's moving to the most productive places in the world. And remember here, one important thing is that productivity is green, right? So if you're very productive, you're green because you're using less inputs per unit of output, right? So at the end of the day, that's what generates the big gains. And so you can see these are the emission changes by 2021 or 2100. So Europe emits less as a result of the tax, but there's leakage mostly into the US, the UK, and Japan because the economic activity essentially moves into those places. Okay, so all pretty straightforward, more or less. There's some changes in economic activity and the distribution of economic activity, but relatively kind of straightforward to understand. Now, let me bring in local rebating. And so what I'm going to do is I'm going to say, well, we're taxing carbon. There's some rebate associated with taxing carbon. I'm just going to give it back at the local level to local consumers. Okay. And so as you're going to see, everything now is going to change, right? Because that's also going to affect the distribution of economic activity. So the first thing is this graph. This is the first graph I showed you. Is again what happens with comparative advantage. So Europe drops. So output drops in agriculture, less in the periphery or Spain, more in Germany, less than in the UK, which is kind of outside. But now look at non-agriculture. Before it was falling even more than in agriculture. Now it's actually growing everywhere, and particularly in the core, like in Germany and some of these countries. And so you're kind of switching this effect, this comparative advantage effect, by which now Europe is actually producing more in non-agriculture as a result of the tax once you give the rebate. Not as much as the UK, but growing a little bit. So that's a very different result than what I showed you before. And so here is at the local level what happens. So, the core of Europe, I'm going to call this the core, and so kind of the big cities too, etc. So parts of France, Belgium, Germany, etc. They produce a lot less agriculture. At the boundaries, less agriculture, but there's still specialization in kind of agriculture at the boundaries of Europe. But what happens in non-agriculture, now you do have the boundary effects, right? Now you do have the boundary effects where these areas are growing, and there's some concentration in the core. It looks fainted, but I mean, this is in percentage terms, and these areas produce a lot of non-agriculture, so it's actually significant. That it doesn't go down. So that means that overall, the non-agriculture is actually growing overall in Europe, and over time, this again, these effects kind of amplify across regions. And so when I look now at what happens in the European Union in terms of real GDP and population, I see something very different. Instead of the declines that I showed you before, now I see increases in both population and real GDP, as long as the taxes are not that large. So 40 again is the level that we were talking about before, right? And in terms of sectoral output, you see increases in non-agriculture and decreases in agriculture. So exactly flipped. And so what happened is that the rebate concentrates population and economic activity in that core of Europe. That core of Europe is more productive than other areas. So you are kind of adjusting or correcting some of the spatial agglomeration and congestion forces that were determining the distribution of economic activity. That is not optimal. And so the carbon tax and the rebate is pushing towards a more efficient allocation of resources within the European Union, but also across areas of the world, in the sense that the European Union is receiving population. Welfare within Europe is still falling, right? So that's the dotted line here, but that's because lots of people are coming in, right? So there's flow of people coming in. And so in the world overall, though, GDP is growing, while before it was falling as a result of the tax. So now for the world, it's good that Europe is doing it. It's not good. I mean, it's good for the environment overall in the long run, but it's also good in terms of both welfare and total GDP or real GDP. And because through this reallocation, through this the spatial reallocation that it generates. Okay, so
was it welfare of the resident population before movement or after?
This is welfare of the world.
No, the previous one.
After. So importantly after, because if you do it, I mean, if you, for example, increase migration so that people cannot come in, then welfare in the European Union is going to go up. Because you're more efficient essentially in the non-agricultural sector, because it's more concentrated in the parts of Europe that are more productive. Okay, and so the point is, and in some sense, this is kind of the basic lesson that I want you to get out of this, that when you impose the carbon tax and when you do the rebating, you're changing the distribution of economic activity in space. And because the distribution of economic activity in space is the result of agglomeration and congestion forces that are not optimized, right? We're in an equilibrium, you're not in an optimum, right? That reallocation can change and potentially can make it better, can create efficiency gains. And in particular, in this case, it moves into the areas that pay the higher rebate are the areas that are the most productive, that attracts people, and that increases population concentration in the most productive places in Europe. I have just a few minutes, but okay.
Here, this has an effect because the tax is paid by landowners and distributed to, labor.
That's true.
Because otherwise, I mean, because you are taking the income effect, no? You take the taxes from the same people and you give it back to the same people that shouldn't have an effect. No, but here it has an effect because I think the landowners don't spend locally and you're taxing the landowners and giving it to workers. Is that?
Everything is rebated to the local workers,
But,
both rents and revenue in this case.
Okay, I'm just wondering, no, it's like, this is due to the income effect of the tax, no? But why is it that, okay, because you are taking the money from the same people and giving it to the same people.
Yeah, but because we're not optimizing, right, that has inframarginal effects on mobility and on factor use within. So so if there was no, I mean, like one way to see it is when would you not have an effect of this policy, right? If all those agglomeration and congestion forces were optimized already with an alternative policy, right? So if you were doing optimal local policy already, right, then those all would be exhausted, and then this wouldn't have this effect.
If I understand correctly, you can rebate in an even smarter way than you're saying.
Absolutely. Oh, absolutely. So you could take the rebate and say, well, let's do optimal local policy with the rebate, and then you would do even better than this. But this is like very plain vanilla, right? I mean, this is not. I mean, I'm not playing like extra tricks on you or if this is like the basic way of rebating. Now, so I'm pretty much out of time. So let me just take a couple of minutes to show you the world. So Africa still loses. Right? They're still they are still sending people. They're sending now people to Europe. They're sending some people to the United States. But the world as a whole, the world as a whole is gaining. And then this is the diff and diff on emissions. So now because Europe is growing a little bit more, now it's you know, there's less leakage, obviously, to the rest of the world in terms of carbon, right? Okay. So final point in the paper. In the paper, what we have is we do two more forms of rebating. One that is European, so rather than just do it locally at the square level, distribute across Europe, same per capita, right? So obviously the periphery of Europe now is receiving more. There's less concentration in the center, so there is less of a good policy, right? Ultimately, in the way that we described, because that concentration in the core is like moving people to the more productive places, which is what the optimal spatial policy would tell you to do. And then we do another one, which is uniform in the world. So that's also sending resources to Africa. That obviously benefits Africa in the sense that you're sending resources there, but it also creates this kind of pervasive effect or bad effect where you are you're keeping them there because you are giving them resources they don't migrate to Europe. And when they don't migrate to Europe, yes, there's a kind of a local growth effect there, but they don't get the benefit of being migrants into Europe. And so ultimately that keeps production in parts of Africa, which is dirty because they're unproductive. Okay. And so ultimately that policy kind of leads to results that are fairly similar to the local, to the no rebating that I showed you at the very beginning. And so this is the last graph I'll show you. This is real GDP for the world. So local rebating the best, European rebating a little bit worse than that. Then no rebating is this one, and then you have the global rebating, which is actually kind of keeping people in some sense in the quote unquote wrong places, the less productive places, which is the overall worst one. Go. Ask your question and then I'll conclude. Okay. So conclusion is a short conclusion. So what did we do? So we have this framework. We want to think about the carbon taxes and kind of the spatial implications of these carbon taxes. And when doing so, what we found, or what it stumbles on you, is this idea that these taxes and the rebating that comes with these taxes is inevitably linked with spatial reallocations of economic activity, and that you need to take these spatial reallocations of economic activity into account to think about the tax and think about the implications of the tax. And how you design that rebating can make you go from unilateral taxes that are not only bad for Europe, at least in the short run, but also for the world, to policies that actually benefit the distribution of economic activity and can benefit the world in terms of welfare, even without really thinking about the other benefits that they will have in the future for climate and productivity down the road. Let me stop there. Thank you.
So we have time for just a couple of questions because we are running out of time. So Gianluca,
Okay.
and then I think David had a question before.
Thank you. Just one comment and one quick question. So the comment is that, I mean, for an outsider who is literature, I think it would be helpful to have if it's possible to solve like the planner problem and show, what the first best is, so that you see essentially where policies have to move in order to improve, and if they move in the wrong direction or the right direction. I don't know whether it's,
Not
it's
feasible.
not feasible.
Not feasible.
That's what
Otherwise,
I-
yes,
that's what I thought.
would love to,
That's what I
but
thought.
I don't know how to do it.
Just because it's
Just
too
because it's
complex.
too complex,
complex,
and in some sense, the tricks that I mentioned about this investment, the competition for land, etc., that simplify the equilibrium problem a lot, they don't simplify the planner's problem.
Yeah, I know it's just that because there are a lot of, there are all these spillovers, agglomeration and so on. So, I mean, that's kind of one policy, but, maybe, I don't know, I mean, there is, easier way to achieve, to improve allocations than, but I know you're interested in this particular
No, but
policy.
that's a very important point. I mean,
Right.
that of course, the reaction is to say, well, but that's a different issue. Let's solve that issue with a different policy.
Yeah, that's
And in some
what-
sense, I agree with that, but my answer to that is, but we don't. We're thinking about carbon policy and using carbon policy without having done that step, right? So we need to think about, if we put it all today, as countries are doing now, right? It is going to interact with those things because that other policy is not in place.
Okay, and speaking of these other policies, I mean, you have a lot of like moving parts in the model, but do you have sort of, local distortions? I mean, local, tax and transfers. I mean, local, sector-specific tasks and stuff that by themselves already distort. I mean, there are a lot of these within the EU. Across countries they're different. I mean,
So my
do you
answer
have,
to
do you
that,
have a margin in the model that takes, this sort of distortion into account?
only to the extent that they are captured in the inversions in the local characteristics of the country.
But
level.
where do they show up?
So
which-
for example, if you have distortions that affect how much you produce in one sector relative to the other, they would show up in the relative productivities at the local level because I'm inverting from the actual use of labor in the different sectors.
You don't have
right?
data productivity that is directly and then residually from the calculation.
Yeah, I'm not, but in some sense, I think that's good because at the end of the day, the productivities that I am using capture already whatever is in place today.
Yeah.
Right. But you can, if you change them, that matters. of course.
Yeah.
I mean, if you want to change them.
Can we have the last question, Ravi, please?
Yeah, just to understand things a bit better. So if I kill any productivity heterogeneity within Europe,
Yeah.
then the rebate case would not lead to an increase in GDP in Europe, right?
Well, there still would be like Europe versus other parts of the world.
Yeah.
But this reallocation towards the core wouldn't happen or wouldn't be, productivity enhancing for Europe or real GDP enhancing for Europe.
Okay. And then the other thing that I was wondering is that, if we think about implementation of carbon taxes in practice, there is often a lot of opposition, specifically from the more rural, less developed part within Europe.
Yeah.
And I guess one thing that we could think of doing is trying to rebate more to those places. But if I take your result seriously, that would be a very bad idea.
Well, it's
there.
not very, very bad in the sense that you do lose a little bit, right?
Yeah.
But
But
it's
you
still
would-
better than, losing the revenue, etc. And that, but if you say, so that was the uniform Europe. If you just go periphery, then you're going to amplify the part that actually lowers the value of the policy. So it's going to be worse under this criteria. Of course, there's a political concern that maybe you satisfy that way. And that's a different type of benefit that is not included.
Okay, well, in the interest of time, we can leave it here. Thank you very much, Esteban.
Thank you.